All right, now we're going to look at drawing or labeling the location of an angle. Okay, so the first two problems I'm doing is when you're actually drawing the angles in standard position. Let me start with number 9. So we have a coordinate plane, okay, and we're trying to draw it in standard position, so we want the initial side to be on the positive x-axis. Then when you're thinking degrees, you're thinking about the amount of rotation for your terminal side. So like if I went all the way around to here, that would get me to 180 degrees, right? And so let me see now. That means I would have used up 180. So I'd still have to go another 45 degrees, which would be halfway between those two, okay? And so my angle would be all the way around to there. That would be the location for 225 degrees, okay? All right, now with radians, my thinking's just a little bit different. Here's where that work with the number line and trying to count in terms of fractions. All right, with radians, remember how this was 0 and this was 180 degrees, but that was the same as pi radians. And so when I'm thinking about this, I'm going to imagine my angle going and taking this amount of rotation from here to here and splitting it into 3 equal pieces. Okay, so if I do that, it might look something like this. Okay, and let me get rid of that little arc I drew earlier. All right, so I wanted to split that rotation from 0 to pi into 3 equal pieces. So I've done that. Then this would be 1/3 pi, or 1 pi over 3, which would be pi over 3. This would be 2 pi over 3. This would be 3 pi over 3, but that just reduces to pi. Okay, so the angle that goes from here around to there would be 2 pi over 3. And I want you to get used to kind of doing that counting to determine where you're located. And since the denominator was 3, we broke up pi into 3 equal pieces. And then we counted 1 pi over 3, 2 pi over 3. Okay. All right, so let's try that with 10 through 13. All right, now on number 10, the denominator is 2. So we want to break pi, here's pi, that amount of rotation. We want to break that into 2 equal pieces. So that means that would be right here. Okay. And so you want just 1 pi over 2. So that gets you from here to here would be pi over 2. So that straight up spot would be pi over 2. Okay. For 3 pi over 4, the denominator is 4. So that means you need to cut your pi amount into 4 equal spots. Okay. And then as you're counting, you should think of this as 1 pi over 4, 2 pi over 4, 3 pi over 4. So this would be the location for 3 pi over 4. Okay. All right, now degrees, you're a little more familiar with that. With 45 degrees, that's half of 90, but there's a negative in front of that. So when you do that one, you want to think about going this way. Okay, 90 degrees. And so the angle we're talking about would be this angle right here, would be negative 45 degrees. Okay. All right, and then the next one is positive 270. Okay, so let's look at positive 270. Okay, so 270. So that would be in the positive direction, which is counterclockwise. We'd go 90, 180, 270. 270 is a quadrantal angle. Be located right here. That would be the location for 270 degrees. Okay. All right, let's do a few more. Okay, let's look at 14, 15, 16, and 17. Okay, 14 has pi over 6. Okay, It has a denominator of 6. So that means when we're looking at this, we want to look at the marks that cut pi into 6 pieces. So there's the marks that do that cut it into 6 equal pieces. You see that? And so if you want pi over 6, that's 1 pi over 6. That would be just this first amount right here. That would be pi over 6. All right. Now, 5 pi over 3 is having us look at, or has a denominator of 3. So we want to look at breaking up pi into 3 equal pieces. And since that angle's negative, I'm going to break it up down here because I'm going to be rotating clockwise. Okay. So to go to 3 pieces, I'm going to look at these divisions. Let me think where the other one would be right here. Okay. So that looks like 3 equal pieces now. All right. And I'm going to be counting around counterclockwise. And notice how 5 is bigger than 3. So that means I'm going to have to actually go all the way past 180 and keep going. So let me draw those in over here as well. There they are. Okay. So let's see where we'd be if we did negative 5 pi over 3. Okay. So let's count around. So this would be negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3. This would be negative 5 pi over 3 right here. And see how I kind of counted like we did on the number line earlier? Get used to doing that. It helps so much when you're trying to think about angles in radians. All right, now let's do 120 degrees. Okay. All right, so 120 degrees, it's positive, it's less than 180, okay? And so we kind of want to think about where it would be. So it's 60 degrees less than 180. All right, so as you're coming around, this would be 90. It's 30 degrees past that, right? So 90 plus 30 more degrees. And see, this 90 degrees was broken. I can see 3 equal pieces. So it would be right there would be 30, 90 and 30. That would be 120 degrees right here. Okay. Or you can think about knocking off 60 from 180, backing it up to 120. Okay. All right. So with this one, I kind of thought of it as 90 plus 30 more. With 210, I might think of it as 180 plus 30 more. Okay, so for that one, let me start. Okay, let me start. I have to go around 180 and then I have to go just 30 more. So that would be just to here. Okay, remember how that would be 3 equal spots. So that would be 30 more. So this right here, this angle that goes all the way from there to there would be at 210 degrees. Okay. All right. And so now kind of getting us ready to consider